Hey there. Today we're in Lesson 5. We're going to look at some application problems using the law of sines. When you have an oblique triangle, that's any triangle that is either acute or obtuse. An oblique triangle can either be acute or obtuse. There's two laws that enable us to use trig functions on oblique triangles. In order to solve a triangle, at the least, you must know a combination of the following. You need to either have one side and two angles, so that could happen with an angle-side angle or an angle-angle-side triangle. You need to have two sides and the angle opposite one of those sides. That would be side-side angle, and that's got a little tricky, ambiguous case to it. The third case, you can have two sides and the included angle, so that would be a side-angle-side triangle. And then the fourth case would be having three sides for a side-side-side triangle. Case 1 and 2, we solve those triangles using the law of sines. In cases 3 and 4, we solve those types of triangles using the law of cosines. Today we're going to look at just the law of sines. So let's say you're given this triangle with sides little a, little b, and little c, and we know angles alpha, beta, and gamma are a, b, and c. We can set up three equal ratios, and these proportions are known as the law of sines. The law of sines equates the ratios of the sine of an angle to the length of the side opposite that angle. When using the law of sines, you have to set up the proportion by equating any two of these ratios. Now, it also works with the reciprocal ratios as well. So you can set up side A over sine of angle A is proportional to side B divided by sine of angle B, and that's proportional to side C is divided by the sine of angle C. So it works either way, whether you put the sine in the numerator or the side in the numerator. Either way is appropriate. And like I said, we use these on oblique triangles, angle, angle, side, angle, or side, side, angle. So in our first example, we have the missing sides to find and the angle that was given. So we have two angles, 82 degrees, and I like to start my triangle. It doesn't really matter the shape. But if you go alphabetical A, B, C and alternate between capital and lowercase, A, B, C, and then repeat that, A, B, C, you'll never go wrong with setting up which sides and the proportionalities. So if angle A is given as 64 degrees and angle C is given as 82 degrees and lowercase c is 14 inches, the first thing we can do is we can find angle B. So the way you find angle B is to take 180 degrees minus the sum of the 64 and the 82 that we were given. So that's going to leave angle B is 34 degrees. So now we know that angle B is 34 degrees, and we can come back and put that into our picture. Now, setting up the first proportion, since we have A, we have C, so I want to find A. A over sine of angle A is going to be proportional to the side that we were given, which was 14 inches, divided by the sine of 82 degrees. So if I want to find angle A, kind of makes a little butterfly here. This is what I want to find, or a bow tie if you would. And right next to it is sine of 64. I want to multiply it by 14, divide by sine of 82, and then I'd know side measurement for A. So we're going to need a calculator to do this. So repeating what I said, side A is the sine of 64 degrees times 14 inches divided by the sine of 82 degrees. So if you go grab your calculator, and I'll do that with you in a minute, we should get 12.71 inches. For side A, 12.71 inches. So switching over to my calculator and setting up a fraction, we have 14 inches times the sine of 64 degrees, and I have a degree mark on my calculator, and we're dividing that by the sine of 82 degrees. And I get 12.706 or 12.71 inches. Now, the next thing we want to do is find side B. So I could do that same thing. Side B is going to be proportional. So we know 14 is related to sine of 82, and side B is related to sine of 34 degrees. So again, I'm just setting up this proportion and replacing B over sine 34. So using our calculator again, side B is 14 times the sine of 34 degrees divided by the sine of 82 degrees. And if you work with me, that should be 7.91 inches again for little side B, 7.91 inches. And we have solved a triangle that was given to us as a angle, side, angle. They gave us two angles and a side, or an angle, angle, side. We had an angle, angle, side. Angle, angle, side. Example 2 has us finding the missing term, missing sides, and the angles given again. So starting with A, lowercase b, capital C, lowercase a, capital B, lowercase c, we know angle C is 22.5 degrees. We know angle A is 40 degrees. And we can find angle B by subtracting the sum of the two angles we were given, 40 and 22.5. So that's 62.5 from 180. So we know angle B is 117.5 degrees. So this angle is 117.5. So we know one piece of the puzzle. Next, we want to set up our ratios. So I have side B, which is 12, and that's 12 feet. So angle B and side B are proportional to side A and the angle, sine of angle A. So angle A, little side A over sine of 40 degrees is proportional to little side B over the sine of angle B. And again, get my highlighter out here. If I need side A, I'm going to multiply sine of 40 times 12 divided by sine 117. That'll give me the length of side A. So going back to our calculator, sine of 40 times 12 feet divided by the sine of 117.5. I believe that's going to give us 8.70 feet. So let's give that a try. So we got a fraction, 12 times the sine of 40 degrees divided by the sine of 117.5 degrees is 8.696, so I've rounded that up to 8.70 feet. And then our last piece of information we need, little c. So little c, our third step, little c is to sine of 22.5 as 12 is to sine of 117.5. And again, if I want side C, I need the sine of 22.5 times 12 divided by the sine of 117.5 to give me side C. And if you follow along with your calculator, that's sine of 22.5 divided by sine of 117.5 should give you about 5.18 feet if we've done our calculations correctly. So there we have an angle side, or an angle side angle. This one was an angle side angle because they gave us this 40, that side, and this 40. This was angle side angle. Now we have the ambiguous case. So what happens with the ambiguous case, we'll have to check that out here. Or am I getting ahead of myself here? When you use the law of sines on a side-side angle triangle, you have to be careful about the number of solutions you should have. It's possible to have one solution, two different solutions, or no solution at all. And that's what we're going to see. So there's a test in case you want to try that out. We'll come back to the test in a minute. But first we have to solve the first triangle if it's possible. And then we have to subtract the first angle that we found in this first triangle from 180 degrees. And this is going to be the ticket. That's going to help us out to know whether we have one triangle, two triangles, or possibly no triangle at all. So like I said, we'll come back to that in a minute. Okay, here we have one that is a side, and an angle. So I'm going to start out here, capital A, B, capital C, A, capital B, C. We know A is 123, little a is 47, little c is 23. So first we want to set up the proportion we have, and we have the sine of 123 over 47 is proportional to the sine of c over its side 23. Now, if I want to find the angle, and I know that my ratio is 23 times sine of 123 divided by 47, that's going to give me the radian measure for the sine. So I'm going to set this up, 23 sine 123 divided by 47. And on my calculator, I've already pre-done this. It was 413. But you see, this is not my angle. This is the value for the sine of an angle in a radian measure. So to actually find angle C, my calculator needs to help me by doing the inverse, because the inverse of both sides is going to give me the radian measure for that angle. So to get that radian measure, and you can see what I've done on my calculator, I put sine inverse of that decimal 0.410413, it gave me a radian of 0.422. And if we take that answer, 0.422, multiply it by our multiplier, 180 divided by pi, that conversion factor, it tells me angle C is 24.23 degrees. So angle C is roughly 24.23 degrees because we had to convert that answer using our multiplier for converting from radian to decimal. So they gave us 0.4229, and we did 180 divided by pi on the calculator, and it told us our value for angle C, 24.23 degrees. This is my first angle I found. Now to get angle angle B, we know that this angle is 24.23 degrees. So what was angle B? We would do 180 minus 123 minus 24.23 on our calculator to get that third angle. 180 minus 123 minus 24.23 gives us 32.77 degrees, or 32.77. Okay, now angle side B, we can set up that proportion, and little side B over the sine of our 32.77 degrees is proportional to that first given thing. I'm going to use the given that they gave us just in case I made a mistake back here. So the sine of 123. So again, with the highlighter for side B, I'm going to multiply sine 32 times 47 divided by sine of 123. And working through that, it should be about 30.33. 30.33. So now we have resolved that triangle. And then to test to see if we have more than one triangle, try to get this dual page on here so we can see. So we've solved the first triangle and we took 180 minus the first angle we found. So what does that look like? 180 minus the first angle I found, 24.23. And that gives us 155.77 degrees by subtracting. And then add the given angle. Well, the given angle was 123. So if we have 155.77 and I add the given angle that can't be changed, I end up with a value 278.77. This amount, when I compare it to 180, this is much bigger than 180. So that tells me because 278 is bigger than 180, I get one triangle, and that's it for that one. So this has one triangle only, and we were told it just had one triangle. Okay? So now let's go on to the next one. Turn that off, and we'll move on to the next one. Now, this one's supposed to have two solutions, so we'll give this a try and see how that works out. So they told us angle A is 35 degrees. So if I start here, A, B, C, A, B, C. So little b is 16, little a is 12, and angle A is 35. So we want to find the first triangle, and I'm going to look for sine of angle B over the side 16 is proportional to the sine of 35 over side 12. And instead of spending too much time, I'm just going to go right for the inverse because that's going to give me the decimal. So my work is going to be 16 sine 35 divided by 12. And I'm going to take the inverse first because that's going to give me the number, whatever that answer is. I'll multiply that answer times the conversion factor and it'll tell me the degrees. So let's go to our calculator and do this little bit of work. Okay, so clear that off, and we're doing the inverse because we want the angle measurement, and we need 16, I'm going to put a decimal there, times the sine of 35 degrees divided by 12, and that's 0.87062, so I want to multiply that times 180 divided by pi. And by doing that, we'll know the degree. So the degree is 49.89 degrees. Because our answer was 870682 behind the decimal. And that told us the angle was about 49.89 degrees. This is my first angle I found, 49.89 degrees. Now angle C, if this is 49.89, angle C is going to be 180 minus 35 minus 49.89, and that would be 95.11. So it would have looked better if I put angle C down here, but this is going to be 95.11. Now the last side, we need side C. So little c over its angle, sine 95.11, is proportional to what was given, 12 over sine of 35. And again, multiplying 12 sine of 95.11 divided by sine of 35 is going to give us our answer for side C. So 12 times sine 95.11 degrees divided by sine of 35 degrees tells us the side is about 20.84. So now we know all of the information about that first triangle. So this side is about 21. And that angle's about 50, and this angle's about 95. Now remember which was our first angle. That was this one, 49.89. So we want to go back to do the test. So I'll go back to that page. So we solved the first triangle, and we found out that we did 180 minus 49.89, and that left us 130.11 degrees. We were given, the angle we were given was 35 degrees. So when we add that up, we get 165.11 degrees. Compare that sum to 180. So 165.11 is less than a 180. That tells me I get two triangles. Okay? Two triangles are possible. Now here's why I said this answer was really important. That 130.11 answer after we did 180 minus the first angle we found, this is our B2 angle. And here's how that works out. Okay, so we had this triangle was given. If A was 35, I'm going to call this the B2. So little a is opposite A and big B is opposite little b, and little a is opposite capital A, and we don't know little c. So since that first angle was found, I said it was 180 minus the 4989. All we did was swing the leg around to make another angle, which gave the 130.11. So angle B is 130.11. That's going to be this one. That leaves angle C as 14.89 by 180 minus this minus that. So we got that. Then the last thing we need to find, so that's 14, is little side C. So little side C over the sine of 1489 degrees is going to be proportional to this given, the A over A. So the 12 over the sine of 35. And once again, using our magic highlighter here, that's the path we're following. So to find little c, we want 12 times the sine of 1489 divided by the sine of 35. And that looks like 5.38 on my calculator. So this one we had two triangles. One where the first angle was 95 degrees, or the first angle was 49.89, and then the second one where it was 30.11. And then the last instance is when there's no solution at all, and you can see what I mean as we go through this. If this is A, B, C, A, B, C, it's kind of common sense even when you try to draw it. If this side is 10 and this side is 20, and we know that you've got this really long side and this side is half of that side, what's happening? That's not going to reach down there. This is too short. But you can't see that always, so it's great to do the math and let's figure that out. So we got the sine of angle B that we don't know, and it's over this long side 20. And the sine of 50 degrees is over a really short side, that's 10. So you know that if this is 50 degrees and the side is 10, then the sine of B has to be much bigger than 50 degrees. Angle B has to be way bigger than 50 degrees to have a side length of 20, because if 10 is the shortest side, the smallest angle is across from the shortest side. So if we did that math, we're going to see on our calculator something that's going to give us that indication. Now, not every calculator says the same thing, so I want to show you what my Inspire does. Remember, I'm looking for the angle measurement. So if I want the angle measurement, I've got to take the sine inverse of the proportion 20 sine 50 divide 10 to give me the angle measurement. So once again, we got the sine inverse and 20 times the sine of 50 degrees divided by 10. Whoop, messed that up. I got a 0 up there. I need a 20. 20. Okay. And you can see that the Inspire says you've got a non-real result. It's not valid for the square root of a negative number. And that's how I know that there's no triangle possible in this case. So when I get some kind of a domain error, then I know that no triangle can be formed. So no triangle possible here. Told me that I had a non-real result. And then our last two examples, you've got a formula for an oblique triangle, and it doesn't really matter too much how you set that up. If I have an angle that's 135 and I have two side lengths that are 8, find the area, that's 8 and 12. So it doesn't matter whether I call this A, B, C, A, B, C. I could say that's A is 12 and B is 8. And I've got angle C. So if I had that, if I had angle C, I would have to have side A and B. So I have the area of the triangle. I have the included angle. See how it's side, angle, side? So I know it's side, angle, side. You don't really have to letter the triangle. You just have to realize it's a side, angle, side. And you can find that area by doing half of the two sides times the sine of the included angle. And on my calculator, I get 33.94, and the units are meters, so 33.94 square meters. So finding angles, finding area of triangles for oblique triangles can be used from these formulas. And then our last problem is an application problem. We have a fire somewhere between two lookout stations. So I'm going to draw a little fire here. This is my fire. And that fire is happening between lookout station, I'll call that A, and lookout station, I'll call that B. And you see they've told us that both stations spot the fire. And the bearing of the fire from A is north 35 degrees of east. So if this is your north line, and this is the bearing 35 degrees that way, then it's this measurement that's 35 degrees out here. And then for angle B, the bearing is north 49 degrees towards the west. So again, if we put a little north-south line for our compass here, and the bearing is going off north 49 degrees towards the west, that's this angle in here. So this is 49 degrees off to the west for that lookout station. Now here's how you'd have to think about the angles inside, right? So we've got, this is going to be 90 degrees, and if I want to know angle A inside the triangle, then I've got to think about 90 degrees minus that 35 degrees, because that's going to tell me angle A is 55 degrees. And if we want to know angle B, we've got to think about 90 degrees minus 49 degrees, which tells me angle B is 41 degrees off of that east-west line. So now that I know that, I know this angle can be found, 55 and 41, that's 96 degrees. So angle C has to be 84 degrees. So angle C is 180 minus the sum of the 55 and the 41. So angle C is about 84 degrees. And they want us to do what? Find side A, how far is to the nearest mile the fire location from station B. So they want us to find side A. We need to find side A. We need side A. And to get side A, we can set up the proportion. A is proportional to the sine of 55, which is equal to the ratio of 13. Wait, where did I get that? Because I missed that. The fire lookouts are 13 miles apart. 13 over sine of 84 degrees. So what do we need? We need sine 55 times 13 divide sine 84. That'll tell us how far apart the fire is from fire station B. So 13. Whoop, that's not right. So A is 13 times sine 55 divided by sine 84. So let's get our calculator and start over with that. So we got okay for that. And we need 13 times the sine of 55 degrees divided by the sine of 84 degrees. So about 11 miles apart, 10.71. So this is about 10.7076 miles. So there we know that the fire, the B lookout, is about 10.7, or to the nearest mile, they said. So about 11 miles from the fire. So they gave us words and we answered in words. And that's the end of our lesson on law of sines. We'll see law of cosines next time. Bye for now.